Okay, let's dive in. Imagine this scenario. You're deep into something important in Proxmox, maybe restoring a VM from a network drive,
Yeah, you're just waiting for it to finish.
exactly, waiting for that server to hum back to life. But instead,
Yeah.
you're just staring at this progress bar that's barely moving.
Crawling along?
And maybe you see that I/O delay percentage creeping up on the dashboard kind of mocking you. Does that sound familiar?
Oh, I bet it does for a lot of people.
If it does, yeah, you are definitely not alone there. This whole struggle, it's a really common theme you see popping up in online tech communities. It sparks this real quest, doesn't it? People trying to find the secret sauce for a faster Proxmox setup.
Absolutely. It's a hunt for those golden nuggets of wisdom.
So we've tapped into that collective experience, all those shared frustrations and maybe some triumphs too, to bring you some solid insights on how to really tackle, maybe even crush these I/O delays.
And what's really fascinating, I think, is how widespread this is.
Yeah.
It doesn't matter if you're a home lab enthusiast just tinkering, or if you're managing a critical server for a small business. It hits everyone.
Yeah.
So our deep dive today, it's really all about understanding what an I/O delay actually is, what it signifies,
Okay.
why it becomes such a pain, such a bottleneck in your system, and then maybe most importantly, laying out this treasure trove of solutions people have actually tried and tested.
Community tested fixes.
Exactly. Stuff that can help you finally get that breakthrough in performance you've been looking for.
We'll dig into some real world examples too, like that one user's quite painful experience trying to restore a VM. They had this specific setup, right? An HPE 4-bay server,
I remember that one.
3 disks in a ZFS configuration, 1 bay empty, and they were wondering, hey, I've got this spare 300 gigabyte hard drive lying around. Could that be the key? Could that speed things up?
A classic question.
Right. And their struggle, it really kicked off a great discussion. So we're going to walk you through the insights from that, the ideas that came out, which hopefully will empower your server to run? Like a dream, finally. So let's start right there. I/O delay. It sounds simple enough, but what's actually happening under the hood? What makes the server just sit there and wait?
Yeah, you're right. The name is pretty descriptive. I/O delay is basically just the time your CPU or your whole system is sitting idle.
Twiddling its thumbs, you said?
Pretty much, yeah.
Yeah.
Waiting for those input-output operations to finish up.
Yeah.
And 9 times out of 10, probably more, those operations are storage-related. Disk reads, disk writes.
Yeah.
So if you see a high I/O delay percentage in Proxmox, that's a big red flag waving at you.
Right.
It's telling you your system's getting choked up somewhere. And usually, the culprit is sluggish storage. It's exactly what that user restoring their VM was seeing. They were trying to figure out, what was dragging down their HPE server.
And it really seems like the community, when they talk about slow Proxmox setups, they almost always zero in on storage first.
Absolutely. That came through loud and clear in the discussions we looked at. Storage is almost always the weak link, the critical bottleneck.
Someone put it quite bluntly, didn't they?
They did. There is always a bottleneck somewhere, and when using HDDs, it's usually storage. Simple as that.
Makes sense.
And hard disk drives, HDDs, they're known for causing these delays, especially compared to solid-state drives, SSDs.
Or NVM drives, even faster.
Exactly. So if your VMs are running on spinning disks, maybe like those Western Digital Reds someone mentioned,
Yeah.
you're almost certainly going to feel that I/O weight pain.
Yeah.
Especially when you're doing something intensive like restoring a VM. That really hammers the disks.
Okay, but what about that specific setup? The original poster had Proxmox OS itself on a 128 GB NVMe drive. That sounds fast, right?
On the surface, yes.
But it was plugged in via a PCIe extension card bought off AliExpress. Could that kind of budget setup, maybe the adapter itself, be causing problems?
That's a really sharp point, and yeah, it absolutely could. It raises a big question about hardware quality and suitability for the job.
Right.
See, low quality or just plain consumer-grade drives, especially when you stick them on, let's be honest, potentially sketchy hardware, like a cheap PCIe adapter, they often just aren't built for the kind of relentless workload Proxmox throws at them.
It's pretty demanding, isn't it?
Very. As another commenter pointed out, Proxmox is really chatty. It's constantly doing logging, handling high availability stuff in the background.
Oh, writing to the OS disk.
Exactly. And that can literally wear out those lower quality, smaller disks surprisingly fast. Maybe within a year or two, they warn't.
Wow. And that leads to slowdowns.
It leads to performance degradation, yeah. Or sometimes just outright failure. Not good.
Okay, so back to that user with the spare 300 gigabit HDD. They were thinking, maybe I can use this as a cache drive for my ZFS pool. What did the community think about that?
Oh, they shut that down pretty quick.
Really?
Yeah, the consensus was pretty clear and pretty immediate.
Yeah.
Using an HDD for cache in ZFS is,
Yeah.
well, one user just called it a terrible idea.
Okay, Blent again. Why is it so bad?
It comes down to speed, right?
Yeah.
A cache is supposed to be faster than the thing you're caching from. A hard drive is just going to be as slow, maybe even slower than the main ZFS disks you already have.
So it doesn't help at all. Might even hurt.
It wouldn't help speed things up, certainly. So the clear recommendation, if you are thinking about caching, was you need an SSD. A SATA or SAS SSD is like the absolute minimum.
Got it. So no HDD caching. Forget that idea. But there was another suggestion that seemed popular, kind of related to ZFS, just adding more RAM.
Ah, yes. RAM.
Someone mentioned DDR4 is cheaper now. Is that really like giving the server a caffeine shot, like a quick boost?
It often can be, yeah.
Yeah.
ZFS, the file system lots of Proxmox users rely on,
Yeah.
is famously memory hungry. It loves RAM. So by throwing more RAM at it, you basically empower ZFS to do more of its work directly in memory, which is obviously way faster than going to disk.
So it caches more data in RAM.
Exactly. It reduces the need to hit the slower storage, especially for data you access often. So yeah, it can feel like a really sudden, noticeable speed boost. Like adding extra lanes to a highway, suddenly the traffic flows much better.
Right. Okay, so ZFS, powerful, but needs RAM, needs care. Beyond just RAM, were there other ZFS tuning tips that came up? Deeper optimizations?
There were. ZFS Performance Tuning is a whole world, really. One
Yeah.
user shared this fascinating story
Oh, yeah.
where their network, they figured out, was actually faster than their local ZFS disks could handle during transfers. It was causing weird, inconsistent performance.
So the network was waiting for the disks.
Kinda, yeah. Their fix was interesting. They actually dialed back their network controller to 1 GBps just to match the disk speed and make things predictable.
Wow, okay. That's counterintuitive, slowing something down to speed things up overall.
It highlights a key principle, though. ZFS performance is always a balancing act. You need all the components working well together. But for a more common targeted fix, people often talk about adding a dedicated ZFS intent log device, the ZIL.
Or slog, separate intent log.
Right, same thing. You use a fast SSD, or ideally an NVMe drive, specifically for handling synchronous writes. Things that need to be confirmed as written right now.
And that helps reduce I/O weight.
Significantly, yes.
Yeah.
It takes that specific, often latency-sensitive workload off your main storage pool.
Okay, I know you can search online for Proxmox ZFS log disk or similar to find guides on setting that up, but there was a really important warning about using SSDs for this, right? For safety.
Absolutely critical point. Any SSD you use for caching, or especially its ZIL's log device, must have power loss protection, PLP.
Why is that so crucial?
Because if the power cuts out unexpectedly while data is in the SSD's cache waiting to be fully written, poof, you can get data corruption.
That's bad.
Very bad. So enterprise-grade SSDs usually have capacitors to handle this. Consumer drives often don't. It's a non-negotiable for reliability if you're using it for ZIL or caching important data.
Got it. Power loss protection, essential. Okay, speaking of hidden problems, there was that really interesting tip about RAID controllers, particularly on older HP servers.
Oh yeah, that was a great catch by one user, a real gem. They had an HP DL380 G7, an older but still capable server. And they pointed out that those HP RAID controllers can become incredibly slow if the right cache is disabled.
And why would it be disabled?
Often because the battery backup unit, the BBU for the cache module, has died. It's old, it fails, and the controller disables RAID caching for safety.
Okay, so the fix could be simple.
Potentially very simple. Their advice was spot on. Reboot your server and check the POSD errors, the messages that flash up when the server starts.
Right, during boot up.
Yeah. It might tell you right there if the cache battery is dead or the module is disabled. This could be a total jackpot fix for someone running similar hardware. A misconfigured or underpowered RAID setup, maybe just due to a dead battery, can absolutely cripple performance.
Turning a decent server into a slug.
Exactly. So if you're on RAID, especially older enterprise gear, take a look during boot. Replacing a battery or just re-enabling right caching in the controller's BIOS, that could be the instant fix you've dreamt about.
That's a fantastic tip. Okay, let's circle back quickly to that user's NVMe drive, the 128 GB one on the AliExpress adapter. That definitely seemed to worry people.
It did, yeah. And for good reason, as we touched on. Consumer drives, especially budget ones, and let's be real, sometimes adapters from less-known sources, they just aren't designed for the 247 grind of a virtualization host.
The constant writes again.
The constant writes from Proxmox logging, HA stuff, VM disk activity, it all adds up. Cheap drives wear out much faster under that kind of load.
Leading to slowdowns or failure?
Exactly. And someone shared a real horror story, didn't they, about a consumer SSD they put behind a hardware RAID controller.
Yeah. What happened?
It basically stalled completely after the drive got filled up once. It needed a manual trim command to become responsive again. Nightmare scenario.
Yikes. Okay.
So the lesson is pretty clear, I think. If your Proxmox OS, or maybe even your really important VMs, are sitting on a budget SSD or NVM, seriously think about upgrading.
To something enterprise grade.
Ideally, yes.
Yeah.
Something with higher endurance ratings and, again, that crucial power loss protection. It's an investment, sure, but it can save you massive headaches and frustration down the line. Avoids that feeling of running through molasses.
Right. Good advice. Now, it's tempting to always blame the hardware, the disks, the controllers. But I/O delays aren't always just hardware, are they? There was that sneaky VM-level issue someone brought up.
Ah, yes. The Windows Disk Optimizer trap.
Tell us about that one.
Well, if you clone multiple Windows VMs from the same template, which people do all the time,
Sure, standard practice.
they might all inherit the same default schedule for running Windows Disk Optimizer, or defrag back in the day.
Okay.
So suddenly, maybe every Wednesday at 1 a.m., you have 5, 10, 20 Windows VMs all deciding to hammer your storage array simultaneously, trying to optimize their virtual disks.
Ah, causing a massive I/O spike.
Exactly. All hitting the storage at once. The fix is usually pretty simple, thankfully. Either disable the scheduled optimization within the Windows VMs.
Which is probably fine for most virtual disks anyway.
Often, yeah. Or at the very least, stagger the schedules. Make VM1 run at 1 a.m., VM2 at 2 a.m., and so on. Spread the load.
Smart.
It's a small tweak, but it can make a really noticeable difference, stopping those sudden performance cliffs. And the same logic applies to Linux VMs too, right?
How so?
Check for scheduled tasks inside the VMs. Things like automated backups, large package updates, log rotations. If they all happen at the same time across many VMs, you'll see an I/O spike.
So coordinating or staggering those internal VM tasks is important.
Definitely. A bit of detective work inside your VMs can really pay off in smoothing out overall server performance.
Okay, we've covered a lot of ground. Normal I/O delay versus problematic I/O delay. When should people really start to worry? Someone mentioned seeing 99% I/O day. Wait, which sounds alarming.
Yeah, that's definitely alarming. Look, some I/O delay is expected, especially if you're using HDDs. They're just physically slower.
Sure.
But when you see extreme numbers, like 99%,
That's not normal.
absolutely not. As one experienced pro commented, they've never seen it go that high in 20 years.
Professionally.
That's a serious red flag. And if your system's load average is climbing way higher than your CPU core count, like maybe triple, as was happening in the original poster's case,
The system is struggling hard.
it's seriously struggling to keep up. That kind of symptom strongly suggests something is fundamentally wrong. It could be a drive that's actively failing,
Okay.
or a major misconfiguration somewhere, or maybe a hardware issue, like that potentially faulty PCIe adapter we discussed.
So if you see those really high numbers, what's the absolute first thing you should do?
Run a smart test immediately.
Okay. How do you do that in Proxmox?
It's pretty easy. You can usually do it right from the Proxmox web GUI under the disk section, or you can use command line tools like SmartTetleel if you prefer.
And that tells you the health of the drive.
It gives you the drive's self-reported health status, error logs, stats. So your first diagnostic step, if that smart test shows errors or indicates the drive is failing,
Backup time now.
back up everything critical immediately and then plan to replace that drive as soon as possible. Don't wait.
Good advice. What if the drive looks okay, though?
Well, the good news there is maybe the issue is something like that cheap PCIe adapter. If the drive itself is healthy, but maybe the connection is bad, swapping out the adapter might fix everything and you wouldn't lose data on the drive.
Right. Could be a simpler fix?
Could be. But start with a smart test. Rule out drive failure first.
Okay. So we've covered the user-specific issues, the community's brilliant troubleshooting. Stepping back a bit, are there other, maybe more advanced or general tips for optimizing Proxmox storage performance that came out of this?
Yeah, a couple things. For ZFS users, we mentioned RAM, but you can sometimes dig deeper into tuning the IRC.
The adaptive replacement cache.
Right. You can sometimes tweak settings to encourage it to use even more RAM for caching if you have RAM to spare. There are tools like ArcStat you can use from the command line to monitor how effectively the RRC is working.
See if it's hitting limits.
Exactly. See if it's constrained by available memory. If it is, Even a modest RAM upgrade, maybe going from 16 GB to 32 GB or 32 GB to 64 GB, can make a really big difference if RSC is starved.
Makes sense. What about tools built into Proxmox itself for checking performance?
Proxmox actually has some decent built-in monitoring,
Mhm.
and there's a handy command line tool called PVPerf.
PV.
Yeah, you just run PVPerf in the shell,
Yeah.
and it gives you a quick benchmark, a snapshot of your storage performance right now. It helps you quickly see if your disks are performing as expected or if they seem unusually slow, helps confirm if they're the bottleneck.
Nice. A quick reality check.
Exactly. And one last point, related to the original problem of restoring from a network drive,
Yeah.
always consider the network path itself. Ensure your network interface on the Proxmox host,
Yeah.
the switch, the network interface on your storage server. Make sure it's all capable and optimized for the throughput you need. If your hardware supports it, moving from 1 Gbps to 10 Gbps networking can be absolutely transformative for those kinds of network-heavy operations.
Right. The bottleneck might not even be the local disk sometimes.
Precisely. It could be the network connection feeding the data.
Wow. Okay, so tackling these I/O delays in Proxmox, it
Mhm.
really is this fascinating mix, isn't it? Hardware choices, SSDs versus HDDs, RAM,
Yeah.
then software tuning like ZFS settings, ZILs, checking those RAID controller batteries.
Don't forget the VM schedules.
Right, optimizing the VMs themselves, like this whole ecosystem you need to look at. But each step you take, whether it's upgrading a drive, adding RAM, tweaking a setting, it gets you closer to that goal, right? A server that actually hums with efficiency instead of just waiting.
Absolutely. And it's amazing how this whole deep dive really started from one person's specific frustrating problem, that slow VM restore.
Yeah.
And look at the wealth of knowledge and shared experience that came out of that discussion. That single problem and the community response has likely helped tons of other people speed up their own setups.
And now, hopefully, everyone listening is armed with that same knowledge, too.
That's the idea.
So the question for you listening is, what's your next move? Are you going to run that smart test you've been putting off?
Check that RAID battery, maybe.
Or maybe finally bite the bullet and order some more RAM or a proper SSD for a ZIL? Whatever you choose, you might be right on the edge of a real performance breakthrough, getting that Proxmox setup to feel like the well-oiled machine it's supposed to be.
We'd genuinely love to hear about your own battles and victories with I/O delay, how you managed to tame it and unlock your server's potential.